Hello and welcome everyone to IXIA and U Nuggets. These are no frills, straight to the point training videos for engineers in a hurry. My name is Chris Gabrielson, and this particular video we're going to be focusing on how to use IXIA's IX load tool to simulate secure HTTP traffic, or just HTTPS, and specifically HTTPS with different encryption ciphers. Some of the use cases for this, one of the biggest ones within the switching world is testing features like encrypted traffic analytics, where we want the switch, router, or just transit device to be able to pick up on some of the encryption methods that we're using and gather a bit of info about just that secure socket. This can also be useful if you just need to simulate any kind of secure traffic through the switch or router. Maybe it's for something unrelated like NAT testing or something like that. Or if we just want to test our ability to inspect secure ciphers. So if you're testing something like a firewall or a router with specific ACL and you want to be able to pick up that L4 info, this is the way you could do it. So in order to begin testing, we're going to start off with, I've got a switch on the left here. For this switch, we've got two interfaces, show running gig 101 and show running gig 1048. These are going to be acting as our HTTP clients and our HTTP server. And over on my IXIA here, I'm just going to double click the IX load application. And while that's loading up, we'll take a quick look at our VLANs. So very simple config. I've got two subnets that are /24s. So VLAN 10 and 20, which are 10.10.10.1 and 20.20.21 respectively. And obviously my two interfaces are going to be mode access. So pretty straightforward. And then they are going to IXIA 11.1 and 9.16 respectively. Now, hopping over to our IX load application here, we could see it started us in this page. If you don't have that, just go ahead and click originate. That'll bring you here. And then we could right click and add network traffic. Now, the first time we do this, the client will lock up a little bit, so don't worry, that's completely normal, happens all the time. And then if I go over to network 1, so I'm going to click network 1 here, and that's going to bring up the ability to configure it. And I'm going to make this my client. So what I want to do is for my address here, I'm going to change this to 10.10.10.2. That's the starting IP of my client. Mask length of 24, increment 1, and I'm going to create 100 clients. So I'm going to leave the default there, and I want them to use a default gateway of 10.10.10.1. Now, if for some reason you needed a .1 Q tag, the way you can enable it is all the way here. So I could do VLAN enabled, and then I could specify something. Let's try that again. There we go. So I could specify something like VLAN 10. If I needed more than just one VLAN, I could do something like an increment of 10 and then a VLAN count of 3. And so that would make VLANs 10, 20, and 30, being that they're incrementing by 10 at a pop. But I don't need any of that .1 Q tagging, so we're going to disable that because we're all mode access here, and I'm going to leave that alone. Now, next up, once I have my network created, I now need to create my client traffic or my client devices. So if I mouse over traffic and hit this plus arrow, I now have the option to open up data, and then I can go to HTTP. So right here is HTTP, and I'm going to click on the client, and it now creates an HTTP client. But before I can configure that client, I want to configure my server first. So I'm going to go over to the terminate, right click over here, and add network traffic as well. So this time it's going to be a lot quicker. And then I'm going to click on network 2, and I'm going to give this an IP range that matches my VLAN 20 subnet over here. So my starting address will be 20.20.20.2. It's also a /24. And instead of 100 servers, I just want one server. And the gateway will be 20.20.21, and it will not increment because there's only one gateway for everybody. So address, mask, increment by 1, count of 1, so I'm only configuring one server. And then once again, this is access port, so I'm not going to configure any of the VLAN options. Once I have my addressing set up, I'm then going to mouse over traffic 2, and I'm going to go to here, my frequently used HTTP, and I'm going to click on server. This is now where we get to configure a bit of the secure side of things. So HTTPS is part of HTTP. If I click on my HTTP server, it gives me some basic, let's move this up a little bit here, gives me some basic options. So for straight HTTP, I can enable HTTP2 if I want, and I could change the port number, but I care about the secure side of it. So I need to click this secure tab and then enable SSL, and that's going to give me ports 443 on by default. Now, let's talk a little bit about ciphers. If you're looking to change the type of TLS that you are using, for instance, if you wanted TLS 1.3 and you enable it, you'll see there's only a certain number of ciphers which are supported for TLS 1.3. Otherwise, if you just wanted any form of secure, then you simply unselect that and you can now have multiple different options. Now, in this case, I'm not going to be going over TLS 1.1, .2, .3, etc. Again, if we just want any sort of secure traffic, we could follow this step. Otherwise, if you know you need something more specific, we could do that as well. But for now, I'm just going to go with an AES cipher. And so we have two options here. There's generic ciphers, or we have very specific ciphers. So if you needed AES 256 SHA specifically, then you would click it here. And the way we add these ciphers is if I scroll down, it's a little hidden by default, but I would do add ciphers to server. And if I had something selected I didn't want, I can simply clear it out. But for now, I'm just going to do the generic AES, and I want to make sure that that's the only one that's selected. Now, what you want to avoid doing, you do not want to click every single cipher here and then add it, because if you do, IXIA is going to yell at you basically saying, hey, some of these ciphers are specific to version 1.3 or 1.2 and you don't have that enabled right now, so we're just not going to run your test. So less is more here. So I would say stick with something specifically. If you don't know, just pick something like AES like I'm doing, and this will get you just basic secure transactions going through the IXIA. So with that being said, my IXIA server is now configured to be secure. And we can hop over to web pages here. And this is what web pages are available. And if you needed more robust web testing, you can actually create your own web page. If you were testing an actual server and you wanted IXIA to simulate what that page looked like, you could do it. But here, these are all just generic web pages. Nothing too special about them, and they all have different sizes. So everything from 1 byte to 8K to 1024, so 1 meg. But just know that all these are available to you. Now, at this point, now that my server is configured, we can hop over to the HTTP client and configure it to go to our server. And I'm going to start off, rather than commands, I'm going to go to settings. And then within settings, I have the option for SSL. And so now here I can enable SSL. I'm going to accept the default, go down, clear the existing cipher, and I'm going to add AES specifically because that's what I added on my server. You need to make sure both your client and your server agree on the cipher. Otherwise, if they don't, they're not going to be able to talk securely. Now, again, if you need something specific, you have that option within the ciphers here. Or if you want a specific version of SSL, you could do it as well. But again, for here, this is just basic connectivity, so I'm not going to be going into some of these configs. At this point, however, we now have enabled SSL on our client, and the default is using HTTP 1.0, and it'll run now secure on top of that. I now need to go to my commands and tell this client what it needs to do. So I'm going to add this command, and then we can see we have some options. So I could get a web page in clear text, or I can get a web page using SSL. And that's what I'm going to be focusing on here is I want to see what this looks like to actually get web pages. Now, if I wanted to put something, I could do that as well. But for now, it's just simple gets. So I'm going to add this. And we could see we now have the option to configure some of the values. So destination IP or port, this is now going to be selected from the dropdown, my secure server, HTTP server 1, port 443. That's the secure. Once I click it, we now see that the client and the server become connected through our DUT, or device under test. This client needs to actually pull a web page for this to work. So if I'm trying to get maybe ET Analytics to look at larger packets, something like a 1024 kilobyte web page will be large enough to show up in my ET Analytics statistics. And then everything else, I could just simply do the default setting for now. All right, so at this point, our traffic setup should now be complete. We have a client and a server, both of which are configured to use SSL, and they have the same hashing method, or rather same cipher method, and the client is going to reach out and get a web page from the server, just like we would typically see with most clients and servers. I now need to configure what ports the client and server associate with. And so I'm going to hop down to ports over here, and I need to add a chassis. So if I look at my Kalo details here, both ports 11.1 and 9.16 are connected to this chassis IP. So I'm going to copy that out, and I'm going to add chassis up front, paste in the IP, and hit enter. Now it's going to take about 20 to 30 seconds for it to find that chassis and load all of the different modules that are available to it. So we're going to hop over to our switch. And what I'm going to do for this test is I want to make sure that IXIA 11.1, which is on VLAN 10, that's going to be my client, and then 9.16 is going to be my server. So if we hop back over to the IXIA, I'm going to get rid of 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so here's 11. So right here, I have port 11, and I want this to be on VLAN 10. That's my client. So I want to make sure that the client, traffic 1 at network 1, is selected. This port is selected. I can now add it. One important distinction here, you'll see that some of these ports have a user ID associated with them. If there's still a user associated with the port you are using, possibly from a previous Kalo case, make sure you right-click the port once it's in this assigned state and clear ownership and reboot port. We want it to be blank like this. If it's not blank, IXIA will yell at you and it will not allow the test to complete. So we're looking for blank ports here, and be aware when you clear it, that's about a 1 to 2 minute process. So you're going to see it go offline for a bit. It might go red as if it's not connected, and then about after a minute or two, it will come back. So with that being said, we've got port 11.1. Now let's get 9.16 and make it our server. So I'm going to open up slot 9, scroll down to 16. I want to select server over here. So now, before I assigned it to the client, so now I'm clicking traffic 2 at network 2, click the port, and assign it. So now this port will be our server, this port will be our client. If for some reason you made a mistake, just click the port, hit this back arrow, that'll put it back in the pool. But for now, we should be all set when it comes to our port assignment. Next up is we need to define a timeline and objective. What exactly is it that we are trying to test? And so we're going to go to the very top here. We have both the server and a client. Here, we're not really testing anything on the server. IXIA is our server. Instead, we're testing the client side of things. And the default is simulated users, which I don't want. If I'm doing something like ET traffic analytics, I want a lot of secure traffic. So I'm going to double click this. And in the menu, I'm going to say, well, let's just make a total throughput of 100 megs per second. So now I don't care how many page loads that needs to be, how many users that is. I just want 100 megs of sustained HTTPS traffic. Once we have our objective type defined, we can now go to this next part, this little graph. And if let's see if I can grab it. There we go. So if I move this graph up, we can now see what IXIA is going to try and do. It's going to start off by trying to go to 100 megs per second right off the bat. It's then going to stay that way for a period of 20 seconds. So down at the bottom, this is time 0. Right here is time 20. And then it's going to take another 20 seconds to gracefully close out all those sockets. That's not super realistic for me. So instead, I'm going to maybe make my sustain time for 5 minutes. This means IXIA will set up, it'll ARP out for the gateway, get some initial sockets going, and then once those sockets are running, it'll keep that 100 megs per second. It'll keep that going for a period of 5 minutes before then taking 20 seconds to gracefully close out all those sockets. Now, if for some reason I wanted this to run for a really long time, I can simply just make my sustain time really large, something like 100 hours, or I can go through multiple iterations. So if I just wanted this to just go constantly, I could say do 250 iterations, and now this will run this test, which is 5 minutes and 20 seconds. It'll run it 250 times in a row. So something like this is great if you just want to kind of leave generic traffic running in the background for a really long period of time. Now, at this point, let's quickly review. I've got my HTTP client and server configured. I've got them on the proper subnet. I've got SSL enabled, and I selected a cipher which matches on both sides. We've enabled the ports that are client and server specific, and we've defined a timeline and objective that we want IXIA to test with. At this point, we should be ready to apply the config and start testing. The way we do that is the top left-hand corner here. I'm going to click Start Test and then select Test 1 from the dropdown. And IXIA is now going to start pushing a whole bunch of configs down below here. You need to be careful. If you ever see the last log as test is unconfigured, that means it failed. And so you got to scroll back through everything that just went by and see if we can figure out why it may not be working. It's not always the most user intuitive, but just be aware this takes a second. But if it's successful, it should automatically switch over to the statistics view, which it did just now. And it starts off by looking at the HTTP client objectives and the server transaction rates. So I should see both of these graphs start being populated if this traffic is successful. And one thing to note is IXIA is not super real time. So in some cases, my test, so we could see here, the simulated users is 1. So that's what these graphs are here. So it's 18 seconds, there's 1 user. At 20, there's 1. Connection attempt rate, we're trying to connect. Even though everything is working properly, typically takes 30 to 60 seconds before it connects. Okay, and here we go, we could see, right, even though everything was working perfectly fine, it took 28 seconds before we started seeing some activity on the server. I found that that's just the way this particular application works, and as a result, make sure you increase your sustain time, because if you only made it the default 20 seconds we had before, it would look as if no connectivity was actually there. But for now, IXIA is now going to start scaling up. So it scaled up here with 1 user, and it realized that it was not at its target transaction rate. So if I were to look at something like my throughput stats graph, so right here's my throughput stats. We started off at 50 meg, but we set a goal that we would like to have 100 megs of traffic. That's what we are trying to sustain. So one of the things that IXIA does is it's constantly applying traffic, monitoring for 30 to 60 seconds, and then if necessary, it's trying to increase the scope and scale. Now, in some cases, you might hit physical limitations of your switch or router, or IXIA's ability to negotiate that. So just be aware, especially if you have a very large scope or large scale, it might take a couple of minutes for it to really ramp up. But ultimately, what I'm looking at here, I could see that my HTTP server transaction rates, requests received, right? So this is kind of a live second-by-second count. So it received 8 here, 8 here. We have same number are successful. And so it's constantly just going back and forth. And we can get a bit of the throughput graphs here in terms of I should be getting about 70 megs per second of HTTP traffic. So if I were to look at my interfaces showing gig 101, I can see I now have bidirectional traffic. And if I were to look at my MAC address table, I've got about half a dozen clients that have been created by IXIA. It can use up to 100, but it created those clients in order to get a certain rate. And one of the things that we could see here now, even, nearly 2 minutes in, IXIA has now shifted, so it's added some additional users. We were at the blue bar here, we were at 2 before. We've now brought it up to 8, which increased our concurrent connections because it's trying to get us up to 100 megs per second. So if I were to look at showing gig 101, If I were to look at this, so this interface is 1 gig per second, showing gig 1048. Let's take a look at this, gig per second. So it's trying to get up to that higher rate right now, but it's quite possible that maybe something in the application is not letting it go to that speed. But ultimately, be aware, you will see these sort of delays. But otherwise, that's how we could set up basic HTTPS traffic. And all the different graphs that we see here are all configurable. So if you wanted to get some more details in terms of what's going on, especially with your SSL connections, we can enable these. So if I were to close out some of the ones I don't care about for a second, close these out, close out. So right here is HTTP client SSL throughput, and we could see at first we were a little slow. We got up to 50 megs a second. Now we're kind of at this 65, and we're kind of fluctuating back and forth here. So we're having some issues getting up to the target rate, but IXIA is just going to keep trying and eventually level off. If we want to look at things like failures, we can look at that here. So if there's a policer or shaper configured, maybe we're trying to see, something is failing, we have that option. And I can also look at my switch, things like show IP ARP. These should all be populated. All these hosts should be pingable as well. So if you want to make sure that there's an actual host there, you can ping it. IXIA will respond, and this is acting just like real-world client traffic. We got three-way handshakes, three-way teardowns. Everything we need is going on right now. And once you're ready to stop your test, or if you need to modify it in any way, you can hop over to the Config tab here. So these two buttons here is what brings us back and forth. So if I click Stats, brings me back to the Stats window. If I click Config, brings me back to config, but this is going to be locked until the test stops. So if you want to gracefully stop your test, you just click this and do a graceful stop. That'll gracefully tear down your connections. But if you just want the traffic generator to stop exactly where it is, you don't care about three-way teardowns or anything else, you could just stop test. And now that will just hard cut all your traffic. It'll take a minute for everything to come back. So here we go, test is just stopped. And now if I want to modify some of my values here, maybe instead of throughput in megabits per second, I want to do connections per second. I want to get at least 100. So you can make that change, restart your test, and then it should be a lot quicker now in terms of its ability to push that config down into the IXIA hardware. And then we'll see it's going to swap over to the statistics view pretty quick, and it'll start your test again. And so if I were to look at things like some of my L2 throughput stats here, and I could look at L2 stats for client, I don't necessarily care about SSL throughput, so let's get rid of that. I don't care about TCP failures. So we can now see in terms of how many frames are sent, approximately what rate they're going at. Don't care about that alert. There we go. So, and then I could look at my throughput objectives and I could see, okay, what exactly is going on. So we've got about 49, let's just call it 50 megs of throughput. If I close this out, I think we were looking at transaction rates. So let's look at that. So here's my transaction rate. So it started off at 6. Remember, we told it we want to get at least 100. But one of the problems here is that I chose a larger web page size. So we might be limited in terms of how many of those web pages we can load at any given point in time. But IXIA, as you can tell, once again, within about 40 seconds, it tried to adjust some of these values. And we could see that it's going to constantly try to scale up relative to the processing power of the IXIA itself, your port speed, etc. So I hope this tutorial was useful. If you have any future ideas for videos you would like to see, please feel free to reach out to me. Or if you found this one helpful, let me know as well. I always love receiving positive feedback. It lets me know I'm doing a good job. So once again, thank you and have a great day.